Okay, let's go back to talking about lmax. We were talking about how lmax repeats within our circuit. Notice that first it's right here, and then it's right there, and that continually throughout this circuit we're able to see lmax repeating. And that's repeating because of this term right here. And it's really repeating because of the sinusoidal behavior of the wave. Now let's consider lmin. Lmin is the distance from the load to the first voltage minimum. Lmin is equal to lmax plus lambda by 4 if lmax is less than lambda by 4. Lambda, that's a wavelength. And it's equal to lmax minus lambda by 4 if lmax is greater than or equal to lambda by 4. So we can always see that lmax and lmin are a quarter of a wavelength apart, and that the minimum and maximum both repeat every half cycle. Now let's consider what we have. Here's a standing wave. Here's my load. And let's suppose that I have a standing wave just like something like this. And this is in the minus z direction. Let's review what lmax is. Lmax is the distance from the load to the first voltage maximum. Right here is the voltage maximum. Lmin is the distance from the load to the first voltage minimum. Here's the voltage minimum. And here's Lmin. These are the only values that we need in order to be able to determine the standing wave ratio or the voltage standing wave ratio. It's the same thing. That is Vmax divided by Vmin. I want to emphasize one point right here. By knowing the VSWR, we do not know Vmax and we do not know Vmin. We know their ratio, but we don't know their absolute values. It just so happens that the standing wave ratio is related to the reflection coefficient in this way. So this allows us to calculate the magnitude of the reflection coefficient. We also know lmax, and lmax is going to be related to the phase of the reflection coefficient. It's going to be the phase of the reflection coefficient plus 2n pi divided by 2 beta. As long as we know the wavelength, we can find beta. Beta is 2 pi divided by the wavelength, so we need to know the wavelength, and that can be found from the frequency, etc. But as long as we know the wavelength, and we can plug beta in, this can be used to find the phase of the reflection coefficient. So this concept of the standing wave can be used to measure the magnitude and the phase of the reflection coefficient, and it has been for years.